Cool, man. All right, let's get started. I think today we're going to just talk about some fun side project stuff you've been working on. You've been doing a deep dive into server components. Obviously, we've been talking a lot about server components the last few weeks on the pod. And man, I don't know about you, but it really helps. These last few episodes,
Yeah.
I noticed in the last few videos of your server components course, the way we have talked about things like suspense and rendering server components and refreshing and updates, all that stuff, it's gotten a lot clearer, in terms of not having to do retakes. It makes me feel like we're cohering around the right language and mental model for how things work. And, we had this episode where we talked about, once we kind of had an aha moment about how the client components work via the serialized RSC payload. The donuts are holes in the payload that reference the thing, and when the code gets executed on the client, when it finally renders on the client, that was like a big step. But you've been building your own implementation, so you probably have an even deeper understanding. You definitely have an even deeper understanding than we did back then. And so, yeah, we thought it'd be fun for you to just kind of talk about that and, yeah, share some of the stuff you've been learning.
Yeah. Awesome. Great intro. Definitely building the, so I guess to start us off, I have been building an RSC implementation, and it has been, dude, it's awesome. Like when you write code, you just understand how things work. And I feel like there's enough RSC implementations out there where you can kind of browse other people's code, see how they're doing things, and start to understand like how the pictures, like how all the pieces come together, what levers you can pull, like how your implementation can be different than others. So yeah, I kind of just want to go into what I've learned and kind of talk. I kind of want to talk about like what is like the main theme. What are the main themes in writing your own implementation, and less about like the actual implementation details? Because I think it's very easy. Like I'm a programmer. Like my flaw is that I can't talk about something without immediately like diving right into the implementation details. But I think it's like how the big pieces of RSC connect together. Just yeah, helped me a lot, cleared a lot of things up, a lot of questions.
That sounds great. I think it's cool too because it helps us tease apart what is actually intrinsic to the RSC paradigm and what are the opinions layered on potentially by a framework.
Yeah. Yes. Yep. So I guess like kind of starting at the beginning, like you think of React server components, they're like React components that run on a server. Therefore, this thing is like analogous to like PHP or Rails. Like web request comes in and just like a bunch of React code comes out. But you still start here. You're still starting with what I'm going to call a traditional browser-based React app. Like you are still, you're writing your own RSC implementation. The very first line of code you're going to write is like you create a component like div hello world, and you're going to call, what are I always forget these.
React
APIs.
DOM.render.
Yeah. You create an app, create root, and then root.render, something like that. But it is that sort of that create React app, that client-side React app, that's how you start off. That's what you're writing, and that code is going to run in the browser first. But then you want to build an RSC. You want like a component that is going to run on the server and then send its result down to the client. And so the second component that you write is going to be a component that fetches, literally call fetch from the server, some endpoint. Let's call it like /RSC. And you're going to make a fetch request to that endpoint. And you're going to get back an RSC payload. Is that what we're calling it?
RSC payload.
RSC payload. Yep. Okay. So you're going to get back an RSC payload. So now you go over to like the server, and this is where you kind of like the second piece you need to implement. You need to implement a server that can send down an RSC payload when someone makes a request to /RSC. And this is where there is a package. It's like React DOM server, and there's one React DOM server webpack that kind of let you build these pieces. Like React provides a lot of the foundation here so that you can build these pieces. But what I used, again, to write implementation details.
Yeah.
I have a node server that can respond to these requests. And basically in this RSC endpoint on the node server, I import a React module and I pass it to one of these React libraries, and it's going to spit out, it's going to like render that component on the server and spit out that RSC payload. And then I send that RSC payload down to the client. Client takes that payload. There's like a component that's responsible for fetching that payload, takes that payload, and then just tries to render it as children.
Cool. So I think even before you pull in the libraries that can let you render a component on the server that's written in JSX or TSX into the payload, you could actually write this endpoint in like an express server and return an RSC payload. You could return a hard-coded RSC payload. And that would be interesting because if you've ever seen, when React first came out, I remember, and JSX was new, people had these web UIs where you would type in JSX and you would see the JavaScript that resulted. But you could also do things like console log children, right? And the return value, JSX, the tree, is like a data object. It's a data format that is like a JSON object. And it has things like type of, which say this is a div. And it has things like props and different, basically the serialized version of a tree. You can see that in client React without dealing with servers at all. And that's how you could think about a tree in this lower level way, right? As a data structure, that's what it is. And so if you wrote div hello world on the client and then you made a fetch to RSC, you get back the serialized version of a tree, which is the RSC payload. You could hard code it and just say like hello from the server, right? In an Express app. You're not rendering anything. Like you're just returning this data structure. And then that would help you understand, okay, so at this point, I'm guessing on the client, somehow you basically call, I guess if you were just going to blow away the whole tree, you could just call react.render, pass in the new tree, this new payload, and then React on the client would take care of doing the diff, right? So that's how you render an update using a tree from the server as opposed to a tree from the client, a new tree from the client.
Yeah.
Is that kind of right?
Yes. I think at a high level, that's right. I don't know. So the actual like encoding of that payload that the server generates, like, I don't know what that looks like. I wouldn't be able to code that by hand. So I would have to, like, if I was going to hard code it, I'd like
Copy
import
the
these libraries, exactly,
Right.
copy the response and then
Right.
have it returned. But
Right.
it is simple enough that you could do a like hello world example.
Yep.
And like anyone familiar with React could kind of squint their eyes and be like,
Right.
oh, I see the
a
tree
tree.
shape there.
Right. Cool.
And then so you could, like, if you're teaching RSC, maybe it's like,
Yeah.
okay, we're just going to hard code an RSC response. Later on, we'll talk about how you actually generate it.
Right. If you're teaching an RSC implementation course.
Yes.
The React developers don't need to know this to write an app, but to help understand. So then you could have your Express endpoint that returns this hard-coded payload, let's say it's reading it from a file or something, and then it finds part of the data and it just does it swaps it out with like new time, right? And so now, or process.env.secret and or some data. And so now you're like, oh, cool. I can do the same thing that I do on the client where I do a re-render of my React app using a new tree based on some state change. But instead of a state change in the client, I'm doing a new render based on a new tree gotten from the server. And it has the server time, or it has an environment variable from the server.
Let's do server time. Server time's a good
Yeah,
one.
server time. So that's cool because, again, to tease apart and to understand the essentials of the paradigm, that's what we're trying to do. You are calling React render with a new tree, but the tree has data that's generated at runtime from the server, and that
The tree itself comes from the server.
It comes from the server, and so it can include anything from the server, a privileged environment at request time, and so. But it's cool because that's kind of like starts to help you understand why you might want to generate a tree on the server. And then we already know why you want to generate a tree in the client, because the client knows things the server doesn't, like where you're scrolled at, or if you have some ephemeral state, or if you have a session on the client, or the server knows things the client doesn't, like the server time, process, connecting to a database.
Database connection, yeah.
Exactly. So I think that's pretty cool how that comes together like that.
Right. So just kind of kind of like jumping ahead, like getting off this like hard coded example, like you can write a component, like literally write a component, load it in your Express app, load it on the server, render it, take that tree, pass it to the client, and then the client has APIs from this, whatever, not going to get into details. Client has APIs from React that it can use to take that tree and then render it and apply diff it. I'm bad with this terminology.
VDOM
diff it on the
Yep.
VDOM diff on the client, so it seamlessly does updates. It's not just like blowing away the whole page and putting it in. But you can see how there is a React app on both sides. There's a client side React app running that's doing fetch requests and putting that new tree in, and then there's a React app on the server that's running those components on the server. Or there's a React process.
React process, right? It's not like a stateful React app in the way it is on the client.
Yeah, I guess a way to say is like both sides are using APIs from
Right.
React.
Right.
So one is rendering the component on the server, and the other is just inserting, diffing that output and rendering it on the client.
But conceptually, they're doing the same thing. It's just the server is like fire and forget. It's like it's sending you a snapshot of the new tree.
Yes.
Kind of. It's like rendering a snapshot, like at time t whatever, and here is what it would be.
Yep. So one of kind of the questions that I wanted to better understand is I've heard people say like when you're, React server component implementations are not something that you can just drop into your app. Like you really need a framework, and you need a framework provided router and bundler. And I wanted to kind of like understand like, well, what is that? Like why? React was so easy because you could drop it into your app. This feels like way more complicated. You need all these tools. So why do you need these tools?
There's never been a React feature that's been added that has required bundler integration, for example.
Yes.
That feels like understanding why that. Yeah.
Yep. So I think the router is kind of the first one to talk about. Like in our example, we have our client-side React app just making fetch requests to that RSC Express endpoint and getting back new payloads with like time included, and then just updating the screen. But eventually, actually, you don't need a router if you're only building an app with one screen.
That's I think that's the interesting place to start. Let's start there before we talk about a router and talk about how you split the code up.
Sure. Talk about the bundling or
I guess
no. Let's talk about
the
let's do
bundling.
the router.
I think the bundling makes sense to talk about before, because again, if we're trying to understand that what the essentials of the paradigm are, you could have no URL, like you just said, no routing. You just load the code, but we still have, like you said, we have code running in the client and code running in the server. So once you have the React APIs that are doing all the things, how does the code get split up? Because there's still that step.
Right. So back to our example where we're fetching the tree with the time from the server. This is working great. And if your only job is to display the time on the screen, like you're done. Your implementation is done. Ship it. But it's React, and eventually we're going to want things to react. We're going to want components that use browser events and state and so on.
Yep. I think even if you said you're done, but there's still, if you are built your implementation, let's say you have a single file for the client and then you have a single file for the server, you still, coming from a world where people are writing a create React app and it takes all of the code and puts it into a JavaScript file, creates an index HTML that loads that script file and then executes on the client. The layer here that is added and why maybe it's harder to just pop it into the thing is because you need that server endpoint.
You need the server, yep.
Exactly. So given if you have these two files, one that renders the client and then one that has an endpoint that renders a server component, maybe even there's only a server component. But let's just say you have, even if you
No, there's not. That you always need that client-side React app.
Exactly. Even if you only had the server component that was showing the time and it could update and do the diff, because of what you said at the beginning, which is you need React DOM.createRoot and render on the client, part of the implementation will be to look at all these files, see what, if anything, is needed from your userland code in there, and then also add React and all the dependencies that are needed on the client. That is your client bundle. So that bundle step is there even before without a router.
No. Well, let's like simplify. You can create an HTML file with a script tag
That loads React.
That loads React.
Yeah.
Loads these React libraries and then creates a React app. I mean, this is like,
that,
again,
so that
this
is the
like,
that is the bundle. That is the
that
bundle.
like single HTML
Yes,
file that
yes.
just inlines all
Yes.
the script stuff and creates root and starts makes a fetch request to the server
Right,
to
right,
get
right,
this
right,
tree.
right,
But
right.
so this is like the absolute simplest
Yes.
like version where you have that HTML file and then you have the node server.
And the node server is running, and that is the important. You have to have that for this hello world example of RSC implementation, which is why that's more involved. Like that.
Yeah, exactly. That is
yes. Yep.
Yep. Okay, so now we get to the point where we want to write a reactive client side React component, something that uses state, attach an event listener and just track the mouse position, something like that. So our server can't like generate that our server can't, that like doesn't make sense. Conceptually, it doesn't even make sense to run on the server because we need to attach an event listener that tracks a mouse. Like that is very specifically client-side code.
It actually makes a lot of sense if you think about the server endpoint returning the RSC payload. I need to write on mouse move equals function and have that running in the browser and the client. So if my server can only send me JSON payloads of RSC payloads, that's not what I'm doing right now. Like that makes sense for getting records from a database. Yeah, give me that payload. I need to write a function that executes in the client in the context of the client React app.
Yes. So your server, like this conceptually doesn't make sense for your server to be able to do. Like your server just doesn't have the tools to express it. It needs a window, it needs a browser. So the server can send over, you had a nice thing, you said holes earlier. It sends over a reference that basically says like, hey client, as you're rendering this tree, when you come across this line, you are going to render a component. This is a client component. So I'm a server. I don't know anything about this. It's a client component. I've been told that this client component is available
At this address.
module.
Yeah.
At this module. It's called mouse tracker and it's a default export. And that's all. Again, I'm a server. I don't know, but I've given you enough information. You can figure it out. So now the client starts rendering this tree. It hits this line and it says, oh, okay, I need to figure out where this thing is. I've been told by the server that this is the counter module and the default export. And so now your client component's responsible for basically getting that component into React. And
Not counter module, mouse tracker module, but yes, mouse tracker.
Oh, I said counter. Yeah. In my implementation, the first thing I did was the counter. But yeah, mouse tracker is a better one because it's like more browsery.
Right.
Yeah. So
I like that term, by the way.
What, browsery?
Yep.
So you have a space that you can call where you can figure out where to return this module. Sorry, you have a function that you write in your browser app, your client side app, that figures out how to get this module and it returns it. It hands it back off to React. And once you do that, React says, okay, great. I have a component here. I've got the props that the server told me to render it with, and I'm running in the browser. So I have all the APIs available. So I can run this component, set up state, effects, event listeners, all that. And the browser just happily renders the page. And all of a sudden you now have a mouse tracker.
That's very cool. I really like the way you personified the server because it helps you understand. I don't know anything about this. All I know is that at this point in the tree, you need to execute mouse tracker component. And it's so cool, man, because React components return JSX. So you're going to get JSX, but you're also going to set up effects and state. And the client, you almost think about it as like mouse tracker is almost not part of your app anymore. It's like a dependency of your app. It's like if back in the day when we loaded like jQuery plugins, you would put them in the script tags and then you would write your code that uses those modules. This is kind of what's happening. So if you go back to thinking about the index.html page, that was the hello world that loaded React, created React root, and then started hitting the RSC endpoint. Now you're going to have like another script tag that says mouse tracker module. And this is where it's also part of the bundling and the step of actually implementing this, right? Because now your implementation has to know mouse tracker is a client side component. It has use client. We need to deliver this to as part of the bundle to the browser so that when the browser gets that instruction, it says, oh, this is a hole in the tree that only I can fill. I need to look up mouse tracker source code, which has already been loaded and parsed in my browser, but not executed. And I need to execute it with this data at this point in time of the tree.
Yep. Just a few things I want to call out here. So like, first, one of the things that's so cool about this is while your client-side app is reading these instructions and figuring out how to load these client components, where to grab them, what's the user seeing? What's on the screen? The awesome thing here is your React app is suspended. So you just get to wrap all this in a suspense boundary. A lot of the implementations here, the suspense boundary is just like a blank screen to kind of simulate that Rails PHP type feeling of like you're going to an app. It's not ready yet. You just see a white screen, but you can do whatever you want here.
That's amazing.
Which I think, yeah, it's so cool. It's just right away, like your very small client side app boots, makes a fetch request, but just right there, it's like already suspended. And so while all this like back and forth between client and server is happening, you're suspended. So awesome part.
I think it's amazing. And I think it's amazing that suspense was originally thought about solving problems like data fetching and animation. And then it just happens to work for this case, and then once we get to the routing part and you don't have a single app bundle, you have multiple app bundles, it's all the same. Whether you're going to get database records or you also need to load mouse tracker for the first time, but you've been running on another route and you don't have it yet. That's like an optimization, but it just all layers in so beautifully.
Right. Now, there's kind of, I want to kind of take like a step back here. And so you're like this client side app and you need to figure out how to get this mouse tracker. And there's a million ways that like we could provide mouse tracker. Like one thing we could do is we could just like literally put it in the HTML file.
Right.
And then when like the API for like, hey, the server told me to find mouse tracker, where do I find it? You're just like, oh, it's right here. It's in the HTML file. Like here's the module I've defined. But that kind of like, this is a point where like the bundler is really important. Once you start doing that, like we are very much right now, the way we've been talking, we're writing two apps. We're writing like this client side HTML app, and we're writing this Express server that's running trees on the server and spitting them back. But really, you want this like single React paradigm. As an app developer, you want to feel like you're writing one app. You want to feel like I'm importing a bunch of components. Some are server components, some are client components, and I'm rendering them. You don't want to think like, oh yeah, this one goes in the HTML file. Oh, this one stays on the Express server. So this is where like the bundler comes in, and why the bundler is so important, because when you write that app that has a mixture of a server component that prints the time, but also imports a client component, that client component can't run on the server. So as soon as you import it and try to run it, like the server side React is like, hey, you're using state and effects. Like, I don't do that. Like that, this is stateful, and like servers aren't stateful. Like this is bad. You can't do this. So the bundler needs to see that there's an import to use client, and it needs to actually not import that component. Instead, it needs to set up a little shim. And that shim is basically like, instead of importing an actual React component, I'm going to import an object. And that object is going to have a very specific shape. It has like a type that's react.client.reference. That's how, this is a term we're going to use. It's like a reference to a client component. It has some other stuff. It has like the ID of that client component. And that's the ID that you hand off to the browser that can try to figure out like where this component is, what it is. So the bundler is like really key here, because you get to write that React server component that reads server time, but is also importing client components. And then the bundler teases those two things apart, and you get a server component that reads time. And instead of importing client components, it's now importing like these, I'm gonna call them like dummy objects, these reference objects that point to components. It can render that on the server, and those reference objects turn into the holes or the donuts that you were talking about earlier.
Dude, that was a great explanation. It's almost like if you had your server component renders time and then it invokes mouse tracker. If you didn't have the bundler, you'd be like, oh, I want to use client React here. I'm going to just like put a curly and do an object that says like type of client component in my tree. And that's going to be the way that I tell the client to switch this out with its rendered output when it actually renders on the client. And then you could write something that's like, oh, if I'm ever rendering an RSC payload from the client, if there's a node in my tree that says like render client component here, right? Then like I'm going to switch that out and import, look it up in my default export based on the ID, and then run it, and then take that JavaScript, that JSX and the state and effects and set that up and then swap it in. But just like you said, that's exactly what the import graph lets you do. It's using the module boundaries and those use client statements to swap that out with a lookup, and you get like a key instead. So that's why rendering that payload, rendering that tree on the server has that property that it swaps these out. And when folks on the React team talk about donuts or holes, they're making sure to communicate that this is why RSC can render client components, but the way they render them is by holding a place in the tree for the client component to actually execute once the code's in the browser.
Right. So now that code gets to the browser starts executing, hits the hole, the donut for mouse tracker, and it says, where do I get this? And now the browser doesn't like, you could like bundle it in the browser, but you like your server, your build step on your server, your bundling on your server. I shouldn't even say on the server. You're bundling
At build time.
At build time, basically put in that dummy thing, put in that dummy object, and then also basically put the client component aside somewhere. Maybe it just wrote mousetracker.js to like the public folder.
It's like this needs to end up in the client. It needs to end up in the index.html file, whereas server time component doesn't.
Right. So like, yeah, it needs to be available in the browser. So I have to put it somewhere so the browser can eventually get it. So you just write it to a file on disk, and then the browser, there's also some like, I'm like intentionally skipping over some details here. There's like, you also, when you generate the RSC payload, you also tell the browser about all the potential client components it could have. There's like a bunch of data you're passing back and forth. But like, again, just trying to stay at like a high level of the theme of it. When the client needs to fetch that, your bundler basically separated mouse tracker, put it in its own file. I guess it was already its own file. It was a client component, but it put it somewhere that's like in a public folder that's easily accessible. So now your client component,
and maybe it ran it through like a roll up or something that makes it into code the browser can execute if you're writing TypeScript, or if you're writing something that uses a feature the browser doesn't have. It's different than running it on your server in a node environment you control, just like it is in when you have a create React app that goes through a build process. But again, you have a fork here where you have your server component. We don't need to do those things with the server component because they don't end up in the bundle.
Right.
But everything that could potentially be used on this tree and the client, we need to run it through, roll it up into a bundle, put it in the index.html as a script reference or whatever. So
let's not even say like roll up or anything. We're just like, we see the mouse tracker. We're going to write it to public/mousetracker.js.
Right.
And then on the client, when it needs to load mouse tracker, it's just, import, like literally the import statement is when run in JavaScript in a browser. It's a like dynamic import.
Yep.
It goes
It
off
works.
and it fetches. It works.
Yep.
That's the best way to say it.
It used to not, for the youngs listening, it used to not be like this. So today it works.
Right. So you can, your browser
and then your
code,
app could suspend. It could hit that and then suspend.
Oh, it is. It's suspended.
It's suspended.
Yeah, it's suspended because that import is a promise that needs to happen. So the promise, so you do an import, the browser is going to go off to your server and fetch mousetracker.js, which your bundler has put inside of this public folder so that the browser could fetch it when it sees that reference. So now the browser has all the code it needs to execute, and it's able to execute all this.
It's awesome.
You're able to render this tree, and you're able to run client components on the browser with the server never even knowing about that. Not with a server just having holes for them, not needing to run.
Like
them.
you said, it's whatever, however you said it. It's like, I don't know how to do this, but I can just tell you what you need to do. You know?
Yeah. I can give you a reference to some
Right.
name.
Right.
So it's really cool. Also, too, just like a little side note here, it made me really appreciate. I know there was a lot of like discourse about why do we have to put client components in their own separate file with use client at the top? Like as an example, Next used to do this. You could do get server side props inside a React component, and Next's bundler would be like, oh, that's server code. I'm going to separate that and run that at request time from the client code, which is like the actual component in the file that's going to run on the user's device. So why couldn't we do that? Like, why couldn't I just write one server component and just have a bunch of components in the middle of it with like
Client features.
Yeah, client features, mark them as use client, whatever. I just want to say, like, as someone that was implementing this, I really appreciated that it was one file, because I wasn't have to parse like JavaScript ASTs, figure out which functions were marked with use client. It was like, no, when I see an import to a file, I'm going to first open that file, and if the first line of that file is use client, I'm going to take it out of the bundle, out of the server side bundle, and replace it with those shim references, and then also just set it aside somewhere so the browser app can request it when it needs it at runtime. Just very, very, like, very simple, very easy. Just something I appreciated. And I think there's a lot of other stuff that here, like, it's easy if to like tree shake things that are only used in like use client or use server. But what if you set up a database connection in module scope, like, and that has side effects? Should that run on the client? It's like, well, no, it can't. It's a database. There's just a lot that's really difficult with this stuff. So I think that could be like a main motivator. But again, like, I think it's really cool that people can implement their own RC things, and the easier we make it for them. It would suck if I had to like sit there and parse ASTs. And
Totally.
Later on, I had to do this with server components.
Server actions.
Server actions.
Yeah.
And it was hard, but I felt like I already had an understanding of the whole model, where like this part, this bundling part, this client part was very much in like the beginning, the first few hours. So like that's something that could have like just created enough friction that, I'll come back to this in a few weeks. I just want to say that like I appreciated that.
That's very cool. A few thoughts. First was that I know that Sebastian talked a lot about them experimenting with different boundaries and ultimately ending up on the module boundary for a lot of the reasons you mentioned. It reminds me of when we used to do open source, and you do open source, you're defining your APIs for your library code, and it is tempting sometimes, especially when you start out, to make APIs that are really elegant and clever. I can call, we had like an ORM in Mirage. You say like user.find1, user.find. Oh, but if I pass an object, I can do like where the first name is this and last name is this, and they're all overloaded on the find method. And eventually most libraries end up doing like, let's have user find take a number. If you want to do where, let's add another one for user.where. APIs that are simpler to define and write, often, this is like, I'm generalizing, but it tends to be true. APIs that are simpler to define and write and easier for the computer to understand end up usually being easier for people to understand too. So, and you see this with TypeScript libraries as well, where someone can make a TypeScript API that is overloaded in 4 or 5 different ways. You can pass a transition of 1 and it's a duration of 1 second. Oh, but if I pass an object, I can specify ease in this and this. To implement that in a generic way on the TypeScript side is really hard. To use it, if you understand what's happening, can be easy, but it can also be confusing because it takes so many different options. So it also came up in Ember. I'm trying to remember the exact example, but it just reminded me of that principle that I think it's something that as you kind of mature as a developer, you tend to favor simpler APIs because, again, they're going to be easier if you come back to them, and both easier to implement, but easier to understand too. And that was one of the big reasons why they ended up going with the module boundary. We can just look at a component in a Next app that does RSC or your RSC app and know this runs on the server, all of it, and or this runs on the client, right? And it's just a module boundary. So I think that's something that's like maybe hard to like swallow when you first see it, but it's something that is like worth that initial friction and it'll pay off. The second thing was I think it's really cool thinking about the story of like I'm rendering a server component at this point in the tree. I need some way to write an instruction that right here we should render mouse tracker once we're running this on the client. And the way you do it is importing a component, which makes it feel, like you said, like you're writing a single app. There's a lot of ways you could have imagined tying those two pieces together, but it feels just as similar as the difference between writing a React component that has state versus like a stateless React component. In a client create React app, you have two React components, one has state, one doesn't, but you still feel like you're using the same paradigm. Even though they behave differently and they use different features, ultimately the backbones, the skeletons of those two components are the same thing. And your React knowledge transfers from one to the next. Now your React knowledge transfers to the server component, happens to be running the server, and it has different capabilities. It can't use state and effects, but it can await a promise and it connect to a database in a privileged environment. But you import it and you render it. So it's like, it's just interesting how you dwindle down what we need to run code in different environments with different features. And when you dwindle it down, you get authoring a component in a file, importing another component and invoking it with angle brackets and passing props. That is like the interface. That's the most important aspect of authoring React, because it lets you compose. And that is like one of the biggest and most important aspects of using React.
I wanna expand on what you just said. A really big light bulb moment for me is, okay, everything we just talked about in this podcast was like how the browser is able to get and execute client components. So like clearly these components are executing on the browser. But if you stop for a minute and you look at that as like, okay, that's just how the system works. If you take a step back, you are writing a single component and you are doing something like component, capital M modal, and then inside of that, it's children, or like server component that fetches data from database, and then close component, capital M modal. And so like as a developer, you feel like you're writing components, client components that run on the server, that run just right alongside server code, because my modal is clearly running with that fetch data from database component right there. So it's like, yes, the implementation or the way it works is like they get bundled and they run on the client. But like the light bulb moment for me was like RSCs let you write client components that run with server code. They let you write client components that run on the server. And when you hear that, you're like, no, that's not what's happening. They're running on the client. But it's like, no, if you open up a file and there's modals and database calls, they're all running together.
Yeah. Modal, capital modal, and then inside capital user table that fetches data. And there's that line between those two in your editor between line 17 and 8. There's a lot happening between that line. If you were to draw a line between those two angle brackets, there's a lot happening between those two. But it's all been abstracted away so that you, as a developer, authoring this page and trying to explain your intent for what should happen here when the user loads this app in their browser and clicks this button, you get to boil it down to just the essence. So
yes. Yep. Let's talk about routing and kind of why we need routing. So
yeah, I know we have kind of a hard stop soon. So
we'll do like 10 minutes.
Perfect. And we'll have to save the server actions conversation for next time.
Yep. So with routing, this is so like when you're it's one of those things where you're like, once you implement it, you're like, I have no idea where to start with this. You can think about like we are going to the server and we're asking the server to generate that content with the server time in it. And so as we click around different pages, like we want a way to signal to the server to generate different content.
Right.
'Cause, like,
So before we even have URLs in your implementation, let's say that when you set up that React app that calls React.render and it's hitting /RSC Express endpoint that's getting the payload, it also has client components. So you can sit there and click state on a counter and increment it. Your app is running. It's responding to user events. And maybe every second it just like hits RSC and that server component time thing updates.
Yep.
So we have a single URL. We have no navigation, and yet we have an app that is able to update on the client and on the server and diff and React render those two things. So that's the starting point. And
Yes.
now you want to add pages.
You want to add like more. You just I want one. This page shows the time. I want another page that shows the date. And so, how do I do that? Well, it'd be nice if instead of hitting, I'm hitting RSC right now /RSC in my Express app to get that render. Wouldn't it be cool if I could say like /RSC like $time to get the content for time /RSC date to get the content for date. And so basically I need a way for my client app to signal to my server, generate different trees. And so this is basically where the idea of routing comes in. You want some way, and I guess like the way this like gets introduced is like these would generally be considered different pages with different URLs. So like this concept of the router's born. But you want some way where as you can ask the server to generate different content from different components that live on the server.
Yeah. Now you could, let's say you had like left and right in a client component React state that you can toggle. If you had that interval that was refreshing your server component tree every second, you could send along other data with it.
Yeah.
In the request, and you could use that to render return different trees from your server component. Let's say one that does time and one that does date. So even still, you can set up this whole, again, what is the essence of the paradigm here? You can use data from the stateful client app that's running, hand it back to the server, and let the server use that as part of its generation of the tree. So I think that's important.
Right. That is more important than the router. It's funny because I like immediately jump, okay, the router is a solution to this, but you're right. You could just have a state variable that's like render date or render time. It's like a state with either date or time string.
Yep.
And yes.
And the server can use any part of the request. If you're loading this in an iPhone, show an Apple logo. If it's an Android browser, you could do this. So you can build a fully dynamic app. But routing in the URL is basically it's like I think of it as a convention for like how to get the minimum version of this that you're requesting, right? And it's all obviously built in with history and everything. But I've come to think of the router and the URL as like an optimization on top of this question of what do we render for this request,
I think you're right. I think you've been like convincing me of this. And I think the way you said that is, you don't need the router yet. You can just attach data to the request when you're asking the server to render. Okay. I kind of want to like jump into the router stuff.
Yeah,
but I'm
do
not
it.
Sure,
so it's an optimization, but we want links and we want URLs and pages and back and forth.
Yeah. So one of the things when RSCs first came out is folks would say, well, it's much better to do routing on the server because if you do routing on the client, you have to download the whole route map, and the client has to figure out what URLs render what components. And that's something I didn't like. I was like, okay, sure, but I didn't really understand it. But doing this implementation made it crystal clear in my head.
Interesting.
So if you were writing just a create React app with a create React app, client-side app, no server components with a router, you would like your main app component would be like a router and then like a bunch of like route URL equals / route URL equals / about route URL, blah, blah, blah. And that component would be like your root component. Each of those like route URL equals / about would have like children of the about component. So it would be responsible for rendering the about component. Now in like a really naive implementation, that would mean you would need to download every single component to bootstrap this app. But for years, there's been tree shaking. So you really only need to download the route map. but the client still needs the full route map. Like the client is fully aware of every single possible URL.
Right, right.
With the RSC example, the routing all happens on the server. The client doesn't know. The client is just sending a request to question mark, like date, question mark time. I could add question mark about. The client doesn't know about that. The server knows about it. And it's pretty nice. It's just, I don't know how to describe it, but it feels nice that the client is just requesting pages. And as the app grows in size and complexity, the client will just request different payloads. Like it doesn't need to know about all the routes and all.
You don't
that.
have
So
to
it really
bail
simplifies the client.
Yeah, you don't have to bail on the architecture. It's like if you render a user table using like server-side data fetching, and eventually you need pagination. It's nice because you can just do that. Whereas if you start with like every record in the client and then you have to start paginating, you have to kind of bail on that. Oh, let's do or doing search. That's a better example. Doing search on the client versus search on the server. Like if you're just building a table, you fetch all the users and then you add the event handler and you search, and you filter down in JavaScript. Oh, this is cool, but once you need 100 or 200 or 1,000 users, you have to move it. You have to bail on that architecture and go to the server and have server.
You can't just put
search.
all users in a piece of state and filter it locally. Yeah.
So it's nice.
So
that
this
the
is kind of like,
it feels like that, where it's like
this is like that, but applied to routes. You don't need to know all the routes ahead of hand. So
that's cool.
And this part was like fun. This is where I was kind of like, you're not trying to understand how all these pieces come together. You're just saying, okay, when my server gets a request to /RSC question mark URL equals /about. Okay, I'm going to load the about component, render it, send it down to the client. Like you can really see it working.
Yes.
And then you get to make a capital link component in that client side React app I was talking about. That's like kind of like your framework's link. And what does that do? Like when you click a link, that's going to set up a transition that sets state on some component. That state is going to trigger a fetch request to your server.
Serializes that state into a URL. Yep.
Into a URL. And sends
it along
that
with
state
the
that you're going to set. So you have a capital L link component. When you click it, you're going to take like this.ref, set it as state somewhere. So you take the links ref, put it as state somewhere. That state is going to now be fetched from the server component. So you make a fetch request. It's like, oh yeah, they just clicked a link to /about. So I set state to page as /about. My component now fetches /about from the server. I get the payload back. I render it. If server has any client references, well, my app is already set up. It knows how to go fetch those. And so you can really kind of start to see this
really
working.
cool.
And that was like,
and then you push state or whatever, and then you add a history item or whatever on the client.
Yeah. I'm not even doing that yet in my app. I need to because
if you refresh, it wouldn't work.
Yes.
Right.
The idea is like when you click a link, you are just, I have a new URL to request from the server. It's basically like going back to your example of date time. You can think of clicking a link. You have like a date link that requests RSC question mark date. You have time link that requests RSC question mark time. Then you can generalize link and you have capital L link and that requests /RSC this.ref, where this.ref is the links ref.
Very cool.
That makes sense, yeah.
Yep. And it's neat too because you realize there's a single RSC endpoint that you're using to update the app over and over again. And keeping the browser history in the URL bar in sync with that, again, it's like a side effect. It's like an optimization. It's not actually inherent to the architecture, but it obviously is something you want to work so that the website behaves as a website is expected to behave. But that's basically, you're just adding the URL as part of the data that you're using to fetch the new tree from the RSC endpoint. And then your RSC endpoint is going to have some way that parses that URL and uses that as a switch statement to determine which tree to render.
You get to add in layouts. You can it's just, there's all this stuff you can do that's just really, really fun. So, okay,
Very
just because
cool.
just because we have to wrap up in 5 minutes, we'll talk about server actions next week because there's like a lot of cool stuff that comes out of that. But I want to say, like, I used a bunch of projects. There's one called we'll link them all in the show notes.
Cool.
But, there's one called Simple RSC, which is the one I started with, which is just, it's awesome. It's Ben Holmes and Dan Abramoff did a stream where they talked about RSCs, and they didn't go into like the implementation details, but they used this project as their RSC server, and it's really good because it doesn't overload you with complexity. It's enough where you can get a real working app, but it's easy enough to understand or hold in your head. So I really
Nice.
appreciate that one. There's one called Tangle. There's one called Mars. There's this Vite abstraction that's going to make it easier to tease apart all these kind of components we talked about called Vinci. And so that has like a lot of examples and kind of like they're spiking on their implementation, so you can kind of see how they did things. And then of course there's Next, which is kind of the complete production ready, like you can use this. So all those were really, really helpful. And
Cool.
kind of seeing what they all did the same kind of tells you it's part of the RSC model, and then seeing how they differed tells you like, oh, that's where you as like the implementer get to kind of insert your opinions into how these things are going to run. And then I do think that one thing I think I'm really excited for is maybe over the next few years, like I had to build all these pieces myself, and they're crappy. They're just like demo implementation, try to understand this. It'd be really cool to see like, okay, we don't make any opinions about how your routing works and how loading, we don't make any opinions about how your routing works. Like you implement the router yourself, but we have like strong opinions about how the bundling should work. So there's like, here's like a bundling library that's going to automatically split up those server components and the use client components and put like, here's how we're going to,
Like, because the shim code you had to write that shim code.
yeah, I wrote everything we talked about. I wrote, and again, like I was able to reference other projects. So like I would not have been able to do this without these reference projects. Like no chance. But yeah, like like it's nice that I can make opinions about how my router should work. Like if I should cache pages and always render from cache, if I should do like a SWR pattern where I render from cache, but then I immediately kick off another fetch request to do a diff. You get to make all you get to make all those decisions up yourself. So like part of me was
But
like,
you don't
it'd be
care
cool.
about the bundling decision, like opinions.
Yeah, exactly.
Yeah.
Or the opposite. You don't care about the routing. Like I just want to do what like Next says to do for routing. But I have like strong opinions about bundling. Like I think that like I have like a bundling algorithm that works really well for medium-sized apps where I just like so like it'd be cool that I think again one of the things that I'm excited for is to see kind of like right now I feel like you have to implement the whole thing, but as the lines,
The boundaries.
and boundaries get kind of they're very, very blurry right now. As they get well defined, as people say, okay, I think this is the best way to bundle, then a bundling library falls out. If you can pull that in and use that, but then have your own router opinions, I think that'd be really cool. So
That's
I'm really
cool.
excited to see where that part goes. And again, just something we've talked about before. I think it being easier to create implementations makes it easier to like share ideas, and I think that just pushes. I think that pushes this whole model forward, and like
If
kind
you
of
have a
like the best ideas just naturally rise to the top.
Yeah,
So-
the deeper understanding you get from going through at the level you did will help you understand how you can use it in the end state of things. You know
Yes.
what I mean? Just like, Dan, when he first released Redux, had a really good course where he basically rebuilt it, and it helped a lot of people understand. And then now, you can string together stores and use Redux for all these things. And so I think, again, having us talked about it these last few weeks, months, and understanding at the level that you're describing, it's like you realize some of the things we were talking about yesterday was like, it's more than fetching data, right? It's kind of like their official answer to fetching data. But if you look at any of the imperative server code in your projects, you can imagine how it would look to wrap it in a component, what it would mean to compose this Stripe checkout component with your client stuff and integrate it with the router. You start getting some really cool ideas for stuff like that. So I think that's really neat. It would be cool if they end up with like, it's kind of what you're talking about is like a spec, right? It's like there's an RSC spec, and there's what is the public API of the spec? It's like React, it's like RSC dot, load client module with an ID, RSC dot, render server tree with this URL and this data. Those are like the boundaries that you need to implement. And then when it's like, render or navigate, what can implement that navigation? It could be a router with caching. It could be a naive router or whatever.
Right.
So that's
I guess
kind of a cool way to think about it.
Yeah, like my routing implementation and then my bundling implementation, like there's not a clean boundary between them.
Right.
They both make assumptions. Like they both have knowledge of how the other works. Like that's how it all ties together. So
I see.
I think as more people create implementations, like a stronger boundary will be defined between those two things, and then you can get a bundler, but write your own opinionated router. Or, I mean, maybe even it's just like, I really like this person's bundler, but I like that person's router, and I'm going to combine them together and put the sugar on top. So, yeah. But yeah,
No, I mean, people are experimenting with bundlers now, like in the last year, more than in the 5 years prior, right? Vite and Bun and all this stuff. And they all have some ways of referencing the output graph with an ID. It's not webpack.require, it's something else or whatever. So if you had that boundary, and then the routing, there's lots of ways to experiment with the router. You want to always to every click to re-render the whole tree. You want a child click to not re-render a parent segment the way Remix and Next work. So there's lots of ways you could experiment.
Yes. Yep.
So that's a really cool thought. I hadn't considered that, but that's neat, man. Dude, thanks so much for sharing all of that. That's a lot of fun, and we'll definitely put links to all this. Is your implementation public? Are you going to put it on GitHub?
I will at one point, not yet.
Not yet. Cool.
Yeah, I'm still
hacking.
Just
Making a mess.
messy land. Yeah.
You showed me the code. It was pretty easy to understand. I have not written any sort of Webpack stuff, barely any, but definitely not in a long time. And it looked good, man. It wasn't a lot of code. I think you mentioned it. You said it's not a lot, but it took a while to understand what to write.
The first day was very much, I went into it with the attitude of like, I'm going to get stuck. I'm not going to have an answer. I'm going to have to figure this out. And that's going to involve like running other people's code, like tearing other people's projects apart. So yeah, it's more like a lot of time debugging,
research and debugging.
Research and debugging. Yeah. It's like research, but it's like wrestling with pigs research. You know what I mean?
Yeah.
It's not like, no, these paths are still being figured out. It's not, I don't mean wrestling with pigs because like the APIs are bad. I mean, like,
they're cow paths. They're not paved.
Yeah.
Yet.
Yeah.
Yes.
And they shouldn't be, because it's like, you want experimentation. You don't want to say like, this is how you do it. This is the only way to do it. So, but yeah, you do hit these moments where like it gets working and you're like, oh, this is awesome. And that's just like, that like brings your like battery energy level like up to 100. And so you're just ready to tackle the next issue. And then like you're parsing ASTs and you're getting frustrated and the battery's slowly draining, and then you get it working and it shoots back up. So yeah, that's how it feels. It was really fun.
That's great, man. Well, I think it's a victory. You did manage to avoid parsing ASTs, right?
No, I'm parsing ASTs.
Oh, geez. I was going to say count. Oh, right. The server actions. Oh, man. I was going to say count as a victory. You avoid ASTs, because I've been there, and it's pretty amazing, but that'll drain the battery fast. But
fast.
We'll have to talk about that next time. But dude, thanks so much, man. That was really interesting, and looking forward to picking up next part of this conversation next week. So.
Okay, cool.
Awesome. All right. Thanks everyone for listening, and we'll catch you later. Bye.
All right. See ya.